Welcome to Sairam Triple YouTube channel. Let us discuss Module 3 Computational Tools Continuation Introduction to Smart Grid Pathway Design. So, pathway design in a sense, it's a roadmap for the smart grid design, right? The design of smart grid involves a coupling tools or technologies. So, different technologies are modernized technologies or updated technologies techniques we're going to use here and to execute the smart grid pathway design, right? So let's move on to the topic. So barriers and solution to smart grid development. Barriers in the sense there is obstacles or some of the ranges will be there. So that we are going to see in this solution smart grid development. Figure 6.1, I mean 6.1 since illustrated the multiplied. I mean next slide we have a figure, we have a diagram. Approach to designing the smart grid, the layers, right? So system planning and maintenance, energy actions. So energy actions will be there in the smart grid techniques. So solution pathway for designing smart grid using advanced optimization and control techniques for selection functions. So electric power grid are highly complex dynamical systems vulnerable to the number of disturbances in a day-to-day operations. Random disturbances from weather and accidents rarely produce wide area. So in the pathway design, if you have a smart grid using advanced optimization techniques, so at present we have a sensor based and then digitalized everything, selections functions, right? And general level automations, we have automation at this level involves the use of addressed computational technologies and new algorithms for dispatch and unit commitment to ensure reliability, stability, optimization, dispatch. So it's a general level, in the sense basic level of automation. Automation at this levels involves the use of addressed computations technologies and new algorithms for dispatch. The system must be reliable and stable, optimal dispatch. I mean, minimum losses, more generation, and then more usage, optimal. I mean, reduction. Unit commitment on the different uncertainties and constraints. So, unit commitment in the sense, so commitment must be there. If suppose this much amount of power is required, that should be produced in the generating stations. So that also we are going to discuss in the next topics. Security analysis also must be there because model for completely for security. So how do we secure our power, smart grid that in the power system components and then power system analysis, or how the circuit breaker operates automatically based on the sensors operations, and how the transformer tap changing transformer will be changing the voltage levels, voltage like ratios and all. Distributed generation control. Distributed generation control in the sense how do the smart grid implemented that integration of distributed generation. Suppose we are generating a solar power plant in the I mean privately we are generating, so that goes to the like power stations and so distributed generation, like implementing of more number of generating stations like solar, wind, nuclear, thermal, hydel power plant. So just distributing the power supply use generation. So next we have so I told you the diagram here, like good power system automation of the smart grid. So the automation difference functions bulk grid level of the transmission system. So the important achieving resiliences and sustainability of the system, the following functions are evaluated: the appropriate intelligence technique proposed, real-time angle, voltage stability, and collapse detection prevention via intelligent based data, reactive power control based on intelligent coordinations controls, fault analysis, reconfiguration schemes based on the intelligent switching operations. See here in the bulk power system automation, now you suppose more number of power supply systems, more number of generating stations um, like integrated and are distributed generation units. So bulk power system automation smart grid in the transmission level, like automation, the general automation. How do we implementing in this. Like if suppose fault analysis occurs in the different power system components or power system generation, that must be monitored, that must be self healed and then self monitoring, so that must be there. So as you can see the diagram, there is a intelligent grid automation, right? So smart grid itself name indicates it's a smart one, definitely it's a intelligent and digitalized and then a smart one, so right. So it's having four sub categories. One is fault stability diagnosis, network switching and control, reactive power control and managing the control coordination, and distributed generation of emergency use, intelligent control and demand reduction, and network switching restoration, minimum losses load balancing, optimal switching, intelligent control schemes for device management. Here in the intelligent grid system, having distributed generation, network switching, network restoration, reactive power control, fault analysis, fault diagnosis, and self-healing. uh, the name itself indicates smart grid. I told you, it's a self-healing, self-monitored and automatic, right? So intelligent controls and demand reduction. So it controls like by using sensors, intelligent, they mentioned, right? So it controls everything, usage controls demand reduction. So some of the power supply consumer demand more will be there, but they are wasting the power supply, so that must be monitored and then that must be controlled. Minimum loss load balancing, optimal switching. So minimize the losses, loads, and then everything. So if suppose minimizing, definitely efficiency will be increases, right? So reactive power control, managing the control coordination. So in this reactive power control, managing the control coordination so it manages the reactive power, operant power flow, and it controls reactive power usage, reactive power into the active power, because reactive power you cannot use, right? So active power only you can use in the power system component. So that also will be there. And fault and stability diagnosis, network switching and control. If suppose fault occurs, if suppose something abnormal condition occurs, automatically it will be monitoring, and then it send the it make a self field, right? And intelligent control schemes and device management. So device also managing by integrating or intelligent controlling, right? So this is a concept of general automation, bulk power automation in the smart grid automation level, right? So next video we'll discuss distribution system automation requirement of the power grid.